Okay, the last thing that we have to talk about in this section is symmetry. Okay, when we are talking about symmetry, there are three ways that your graph or your equation can show symmetry. It can show symmetry with respect to the x-axis, the y-axis, or the origin. Okay, so we're going to go through each of them one by one, and then we'll work out a problem where you can see how we apply this. Okay, so the first type of symmetry that we have is symmetry with respect to the x-axis. So the definition says a graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, the point x negative y is also on the graph. So if you look at this picture here, if you want to think about symmetry, it's like, so if you are saying your graph is symmetric with respect to the x-axis, you are saying if I were to fold my graph along the x-axis, would both pieces of my graph match up? If you can say yes, then you can say, okay, yes, my graph is symmetric with respect to the x-axis. If it isn't, that's okay. It just doesn't display that type of symmetry. So an example of that, if a graph is symmetric with respect to the x-axis and the point 3, 2 is on the graph, then the point 3, negative 2 is also on the graph. So that means if you have 2 points that have the same x value, their opposite y value should both be on the graph because both halves, when you fold them, should match up. Okay? That's the first type of symmetry. The second type of symmetry that you have is if your graph is symmetric with respect to the y-axis. So same concept, we're just folding it in a different way if you want to think about it like that. So the definition for symmetry with respect to the y-axis says, a graph is said to be symmetric with respect to the y-axis if for every point xy on the graph, the point negative xy is also on the graph. So this time, if you want to think about the fold, if you're saying your graph is symmetric with respect to the y-axis, it's like you are folding it along the y-axis. If both pieces of your graph match up, then you can say, yes, my graph is symmetric with respect to the y-axis. If not, that's okay. It doesn't have to be, but it could show this type of symmetry. So our example says if a graph is symmetric with respect to the y-axis and the point 5,8 is on the graph, then the point negative 5,8 is also on the graph. So if we have these 2 points that have the same y value, their opposite x values must also be on the graph. Okay? And the last type of symmetry that we have is symmetry with respect to the origin. So this definition says a graph is said to be symmetric with respect to the origin if for every point xy on the graph, the point negative x, negative y is also on the graph. So this time, if you want to think about it, it's like your graph makes 2 folds. It folds itself along the y-axis, and it also folds itself along the x-axis. If you can make both of those folds and your graph is still symmetric, you can say, yes, your graph is symmetric with respect to the origin. So in this example, it says if a graph is symmetric with respect to the origin and the point 4, 2 is on the graph, then the point negative 4, negative 2 is also on the graph. So that means if you have a point and its positive values, x and y, are on your graph, then in order for it to show symmetry with respect to the origin, both the x and the y coordinate both need to be negative in that other point that is visible on the graph. Okay. Awesome.